you have held a coin in your hand before. Cold metal, scratched edges, something small enough to forget in your pocket, something ordinary enough to ignore. You drop it on a table, and it makes a sound that feels solid, real, present. Now imagine leaving that coin outside, not in your backyard, not in your city, not even on Earth. Imagine placing it somewhere so distant, so cold, that even sunlight arrives weak and tired. Somewhere where the sky is not blue, but thick and orange. Somewhere where the ground is not rock or soil, but frozen chemicals and slow rivers of liquid gas. Now imagine walking away and waiting 20 years, far beyond Mars, beyond the asteroid belt, out past the giant planet Saturn and its rings. There is a world called Titan, a moon larger than the planet Mercury, a place wrapped in a dense atmosphere where sunlight is dim, like a permanent sunset. And in January 2005, a small human-made object touched its surface. It was called the Huygens probe. It did not land with a roar. It did not arrive with fire or drama. It fell slowly, quietly, parachuting through a sky no human eye had ever seen directly. It drifted for over 2 hours through thick orange haze, sending back images of a world that looked strangely familiar and completely alien at the same time. Then it landed, softly, and for about 90 minutes it spoke. It sent data, images, measurements, tiny fragments of knowledge traveling across more than 1 billion kilometers of empty space back to Earth, back to us. And then it went silent. No explosion, no final message, just silence. The kind of silence that does not end. Now it has been 20 years. That small machine is still there, still resting on the surface of Titan. No one has touched it. No wind has blown it away. No life has disturbed it. It is alone. And the question is simple. What does it look like now? Not in theory, not in imagination, but in reality, after 2 decades on one of the strangest worlds in the solar system. To answer that, you have to understand where it is and what time means. On Titan. You are standing on Titan, or at least you try to imagine it. The sky above you is not clear. It is thick, heavy, a dense atmosphere made mostly of nitrogen, like Earth, but filled with methane and complex hydrocarbons. It blocks most of the sunlight. What reaches the ground is faint, scattered, orange. Even at noon, it never gets bright. The sun is still there, of course, but from this distance, about 1.4 billion kilometers away, it looks 100 times dimmer than it does on Earth. A distant, pale disk, barely strong enough to cast shadows, and yet shadows exist. Huygens saw them. As it descended, its cameras captured channels carved into the surface, branching patterns like river systems, shorelines, flat plains, rounded pebbles. It looked like Earth, but it wasn't, because on Titan, water is rock. At surface temperatures of around minus 179 degrees Celsius, water freezes into something as hard as granite. Rivers do not flow with water. They flow with methane and ethane, liquid gases that would boil instantly on Earth. Imagine standing beside a river watching it move. Not water, fuel. That is the world Huygens landed on, and when it touched down, it didn't hit solid stone. It pressed into something softer, like wet sand, a surface made of organic material, shaped by slow, cold weather over millions of years. For 90 minutes, it measured everything it could: temperature, pressure, wind. Then the battery died, and that was it. But Titan did not change when Huygens stopped speaking. Time kept moving, slowly. A single day on Titan lasts about 16 Earth days. That means the sun rises and sets far more slowly than we are used to. Light changes gradually, almost imperceptibly. And seasons? 1 year on Titan is nearly 30 Earth years. So in the 20 years since Huygens landed, Titan has not even completed a full orbit around the sun. It is still in the same long, slow seasonal cycle. That matters, because it means the environment around Huygens has barely changed. No rainstorms washing it away, and no rapid erosion, no sudden shifts, just slow chemistry and cold. The cold is constant, relentless. At -179 degrees Celsius, almost nothing moves quickly. Chemical reactions that would take seconds on Earth can take years. Materials become brittle, metals contract, electronics freeze into stillness. Huygens was never designed to survive long after landing. Its systems froze, its circuits stopped, its warmth, generated by internal power, vanished. And then it became something else. Not a machine in operation, but an object, a relic. Over 20 years, Titan has been touching it in the only way it can. With wind, with haze, with slow, invisible change. Titan's atmosphere is thick, about 1.5 times the pressure of Earth's at the surface. Winds move across the plains, carrying tiny particles of organic material. Not dust like on Earth, but complex carbon compounds formed high in the atmosphere and slowly falling down like soot. Every day, if day still means anything here, those particles settle, layer by layer, a thin coating, then another. Over time, Huygens is being covered, not buried quickly, not swallowed, just slowly, dusted, like an abandoned object in an empty room. But the room is a world, and the dust is made of chemistry that does not exist naturally on Earth's surface. There is another force at work, methane rain. On Titan, it rains, not water, but methane. Observations from orbit have confirmed clouds, storms, and rainfall. Entire lakes and seas filled with liquid hydrocarbons. But rainfall is rare and seasonal. In the region where Huygens landed, near Titan's equator, rain does not fall often. It may have rained once, or not at all, in the time since the landing. If rain has touched Huygens, it would not rust like metal on Earth, because there is no oxygen to cause rust. Instead, liquid methane could wash over its surface, carrying particles away, reshaping the thin layer of settled material. Then it would evaporate, quietly, leaving no trace of motion, just a slightly different arrangement of matter. There is no sound, no birds, no insects, no movement except wind, and even that is gentle. During its descent, Huygens measured wind speeds of just a few meters per second near the surface. A soft breeze by Earth standards, enough to move particles, not enough to move the probe itself. So after 20 years, Huygens is almost certainly still exactly where it landed. Tilted slightly, resting on a surface that has not shifted beneath it. Its parachute may lie nearby, spread across the ground like a frozen fabric, also collecting the slow fall of organic haze. Nothing dramatic has happened. That is the point. Because in a place like Titan, change does not come in moments. It comes in centuries. Here is the part that hits hardest. If you could stand next to Huygens today, you might not immediately notice anything different. That is how slow this world is. 20 years on Earth feels like a lifetime. Cities change, people age, entire technologies rise and disappear. On Titan, 20 years is barely a moment, less than a season, less than a breath. The probe has been sitting there, untouched by human hands, for longer than many people watching this have been alive. And yet, from Titan's perspective, it has just arrived. That is the scale. That is the difference between human time and planetary time. And it leads to a quiet, unsettling question. If 20 years means almost nothing there, what would 100 look like? Or 1,000? Or longer? What does a machine become when time stops mattering? The Huygens probe is not dead in the way we usually think. It is not broken metal scattered across a landscape. It is not lost in motion or destroyed by impact. It is simply still, a small object sitting in a vast place, unchanged in any way that matters to us. And that is what makes it powerful, because it reveals something uncomfortable about time. On Earth, everything feels urgent. We measure life in years, sometimes in days. We watch things age, decay, disappear. We expect change. We are surrounded by it. Nothing stays still. But Titan is different. It is a world where stillness dominates, where cold slows everything down to the point that change becomes almost invisible. And in that stillness, Huygens remains, a message frozen in place, not transmitting anymore, but still carrying meaning. It is a reminder of a moment when humans reached across 1 billion kilometers and touched another world, not with footprints, not with flags, but with instruments, with curiosity, with a question. What is this place? And for a brief window of time, Titan answered. Then it went quiet again. The probe did not come back. It could not. There is no return from Titan with the technology we had then. It was a one-way journey, a deliberate loss. We built something, sent it into the dark, and accepted that it would never be seen again. That matters, because it shows what exploration really is. Not control, not ownership, but contact, brief, fragile contact, and then distance. Right now, as you sit here, that probe is still out there. The signals it sent have long since arrived. The mission is over. The data has been studied, analyzed, turned into knowledge, but the object itself remains, cold, silent, waiting in a way that is not really waiting at all, because nothing is coming for it. Not today, not tomorrow, maybe not for decades, maybe longer. And yet, it does not disappear. In a strange way, it has become part of Titan, another piece of its surface, another object shaped slowly by the environment around it. Given enough time, thousands, maybe millions of years, it will change. Materials will break down, structures will weaken, it may collapse, fragment, blend into the ground, but that process is so slow that, for now, it might as well be eternal. That is the final shift in perspective. We think of human creations as temporary, fragile, disposable, but place them in the right environment, cold, still, distant, and they outlast us. Huygens may remain recognizable long after the people who built it are gone. Long after the mission is forgotten by most, it will still be there, a quiet artifact on an alien world. And that leads to one last thought. If someone or something were to stand on Titan in the distant future and find it, they would see evidence, not of life, but of intention, of a moment when something, somewhere, reached out and said, "We are here," even if no one is there to hear it now, even if no one ever will be. The probe does not know this. It cannot understand the weight of its own existence, but we can. We can look at that silent machine sitting under an orange sky and recognize what it represents, a small act in a very large universe. And maybe that is enough, because in the end, the Huygens probe is not just a machine left behind on Titan. It is a marker, a point in space and time where curiosity overcame distance, where something small touched something vast and stayed there, quietly, forever.